Our world needs maths. Up, up, and away. Why does our world need flight? Some applications of flight in today's life are travel, transportation, drones, delivering goods, crime fighting, life support, aid, search and rescue, monitoring wildlife, international aid, medical equipment and assistance, and defense.
There is lots of mathematics involved in flight. Acceleration is one aspect of this mathematics. Our video investigates the acceleration of different objects. The acceleration has to be great enough to get the aeroplane off the ground. We use mathematics to calculate the acceleration required.
Based on a Boeing 747 traveling down the runway to reach a takeoff speed of 290 km per hour, we can calculate the acceleration experienced by the airplane during this time. First, we need to convert 290 km per hour to meters per second. To do this, we multiply 290 by 1,000 to turn it into meters, and then we divide by 3,600 to convert to seconds. This gives us 80.55 meters per second.
To calculate the acceleration experience, we subtract the initial velocity from the final velocity and divide by the time this takes. We know that an aeroplane spends about 30 seconds on the runway. We arrive at an acceleration of 2.685 meters per second squared.
Next, we calculate the acceleration of the airplane to the cruising altitude. The velocity of the plane at this altitude is approximately 907 kilometers per hour. First we need to convert 907 kilometers per hour to meters per second. We follow the same procedure as before to arrive at an answer of 251.94 meters per second.
We know this takes about 17.5 minutes. We need to convert this to seconds. This is 1,050 seconds.
To calculate the acceleration the plane experiences during this time, we subtract the initial velocity from the final velocity and divide by the time. So we subtract 80.5 from 251.94 and divide by 1,050 seconds. We arrive at an answer of 0.163 meters per second squared.
As a comparison, we research the acceleration experienced by a drag car that travels the quarter-mile strip in a 15-second time period. First, we need to calculate the velocity of the drag car by dividing the distance traveled in meters by the time it takes to travel that distance. A quarter mile is about 398 meters, and we divide by the 15 seconds to arrive at a velocity of 26.53 meters per second. We can see this is just over a quarter of the speed of the airplane.
To calculate the acceleration of the drag car, we subtract the initial velocity from the final velocity and then divide by the time it takes. In this case, we subtract 0 from 26.53 and divide by 15 to arrive 1.77 meters per second squared.
As a further comparison, Nicholas ran 50 meters down our school oval, and we timed how long it took from a standing start. An initial velocity of 0, it took Nicholas 7.5 seconds to travel this 50 meters. We use the same formula to calculate the final velocity of 6.67 meters per second and an acceleration of 0.89 meters per second squared.
As another comparison, we kicked a soccer ball 20 meters. It took 3 seconds to travel 20 meters. This is equivalent to a velocity of 6.67 meters per second and an acceleration of 2.22 meters per second squared.
The basis of this maths can be used in the future to maneuver drones to access areas that are unable to be easily reached, to allow supplies such as food and water to be delivered to places in need. Flight is a necessity to our everyday world. Our world needs maths.